Composite figure is shown. Based on the information, what is the total area of the composite figure? So our important word here is going to be the area, and the question is asking us to find the area of the composite figure. Now, what is a composite figure? That is just a figure made up of different shapes. Okay? So we need to find the area of this composite figure. So everything is composite, it's made up of different shapes. Now, we might not be able to identify the different shapes as is. So when you see a question like this, what you need to do is you are going to split the figure into shapes that we can easily identify. All right. So for example, when I look at this, I am seeing some stuff that looks like a rectangle, but as it is right now, it doesn't really look like a rectangle. So I'm gonna cut it so that I can see the rectangles. All right. So when you are cutting, we gotta be careful. So when we cut, we always wanna go from the corner. So you would not cut it like that. That's gonna give you extra work. So you try to look at the corners. You can choose to go that way, or you could choose to connect that way, or you could even go this way and that way. All right. So I'm gonna choose to connect or to cut my figure like that. So when I cut that figure, you can see that I have made a rectangle up here. And for this one down here, I'm gonna cut it like that. All right, so now we have 3 different rectangles. So we have one rectangle here, one rectangle here, and one rectangle here. So I'm gonna just use 3 different colors just to differentiate. So this right here would be one of my rectangle. So I'm gonna color this. And in your exam, you may not have colors, but you probably could number it like rectangle 1, rectangle 2, rectangle 3, or you could even use letters and name them. All right, so that's one rectangle. I have another rectangle right here. So quickly color this rectangle. All right, so this would be the blue rectangle, and then I'm gonna choose a different one, a different color. So right here would be the green rectangle. So the question asks us for the area of the composite. So because we have to find the area of the 3 different rectangles, and then when we find the areas of those, then we would combine them to get the area of everything. So they are all rectangles. So the shapes here are rectangles. So we're going to go to our formula sheet, and you're going to look where it says area. So be careful because you have area here and area here, but this is speaking about lateral surface area, and this one is speaking about total surface. So the important thing here have been the surface area. So we're not going to be using this one. We're only going to be using the one that says area. So the shape that we have is rectangle. So we have this one and we have this one. It's just 2 of them. You can choose any one, but I prefer choosing the first one, which is area A is equal to L, length, multiply W, which is width. So we're going to copy this formula onto our paper. So I'm going to put my rectangle, and I'm finding the area of the pink one. So the area of the rectangle is going to be the length, L, multiply L times width. So if we go to our pink rectangle, which is this one, our length, it is 12 meters long. So right here where it says length, I'm going to put 12 multiply. So LW means length multiply width. How wide is it? It is 3 meters wide. So you put 3 as the width. And you can use your brain or your calculator. What is 12 multiply 3? So we have 12. That is not 12. 12 multiply 3. Enter. And that gave us 36 meters square. So if we're talking about area, the area is measured in square unit. All right, so that's the area of the pink rectangle. Now we're going to move on to the area of the blue rectangle. And we're going to use the same formula again because they're all the same shape. So area of a rectangle is the length multiply the width. All right, so now we're going to look at this blue one. Now we want the length of the blue one. For this one, we have to be very, very, very careful. So the length of the blue is from here to here, okay? This 12 is not the length of the blue. This 12 is the length of the whole thing. So from right here all the way up here is the length of, which is 12. However, we want the length from right here to right here. Now, if you look at here, we notice that over here has a length of 3. So it means that from right here to right here, the length will be 3. Why is it 3? Because if right here is 3, then right here would have to be 3. Okay? All right. So this part has to be 3. Now, if the whole thing needs to be 12, then what would be the length from right here to right here? What would that have to be? It would have to be 9. Why is it 9? Because the whole thing needs to be 12. So if this part is 3, 9 plus 3 is 12. So the length of the blue would be the 9 right here. So we're going to have 9 multiply the width. How wide is it? So we want to know how wide is it. All right. So I think I can use down here. So down here, the whole thing is supposed to be 15, the whole thing. However, from right here to right here is 10, means that from here to here is also 10. So I'm saying that from right here to right here is 10 meters. So then it therefore means that from right here to right here would have to be 5 meters. So the 10 meters here and the 5 meters will give us that 15 meters. So the width of the blue is going to be 5 meters. All right. So you can use your calculator or your brain. What is 9 times 5? So you just go to your calculator. 9 multiply 5. So 9 times 5 is 45. So we're going to put 45 meters square. Okay. Now we're going to move on to our green rectangle. So I'm going to put rectangle. And the same area for the rectangle is going to be the length times the width. So this one is an easy one. So for the green one, you notice that the length right here is 10. From here to here is 10. So we're going to put 10. Multiply the width. So right here is the width. So right here has to be 3. So that's going to give us 10 times 3. You can use a calculator. You can use a brain. That's going to give us 30 meters square. So in this case, we would have to add all these three areas, because the question is asking for the area of the composite, which is everything. So now we're going to take our 36 meters square, and then we're going to add that to our 45 meters square plus our 30 meters square. And then when we add everything, you can just quickly use your calculator or you could use your brain. So 36 plus 45 plus 30 gives us 111 meters square. And that would be the area for this composite figure. All right, we're going to move on to our second example. All right, so here we have a composite figure. It says a composite figure is shown based on the information, what is the approximate area of the shaded part of the diagram. So we just want the area of the part that is shaded. All right, so if you look here, we have shaded and we have unshaded. So what we need to do, we're going to have to find the area of the entire shape. The area of the entire shape is a square. This is the entire shape. Minus the area, or subtract the area of the unshaded. So the unshaded would have been some semicircles, or you could see that it is two circles. This half and this half makes one circle. This half and this half makes two. So this half and this half makes one, and these two half makes one. So in total, we have two circles. All right, so we're going to have the whole. So the entire figure, sorry, let me just write that down. The entire figure is a square. And then we have the unshaded. We have two circles. So we're going to find the area of the square. And then we're going to find the area of the two circles. So let's start with the square. So as it says before, our important word down here would be area. So we're going to go to our formula sheet and we're going to look for area, and now we want that for a square, and we see it right here. Area is equal to S square. So area is equal to S. S means the side of the square, the length of the side, square. So let's go to our square. So notice here, inside here, so this is the length of the square that we want. So we want to know what is the length down here. All right, so if you notice, it has this 1 mark, 1 mark, 1 mark, 1 mark. Anything that has this 1 mark means that the length is going to be 10. So what that means that the length over here is going to be 10 centimeters, 10 centimeters, 10 centimeters. So it means that from here, so from here to here, is going to be 10 centimeters. Okay, so now we want to figure out what is the length from right here to over here. What is that length going to be? Same thing here. What's the length from here to here? Now, all of this, the length of all of this is 10 centimeters, and you can see the semicircle that is attached to it. So then it means, therefore, that right here would be the center of that semicircle. Okay? So our center would be right here. So if this is the center, the segment that goes from the center to the circumference would be the radius. So the radius would then have to be 5. So this part has to be 5 centimeters. Now, if the radius goes from the center to the circumference, therefore this is also a radius, 5 centimeters. All right, so if this is 5 centimeters, then right here has to be 5 centimeters. Over here would also have to be 5 centimeters because from here to here is the radius. From the center to the circumference is 5. From the center to the circumference is going to be the same 5. So over here is 5. So the length of the entire square, all of down here, would have a length of 10 plus 5 plus 5 gives us 20. So that is 20, 20, 20, and 20. So to use the formula, we're going to have 20 square because the length of the square is 20. So you go to your calculator, you just put 20 square, and 20 square gives us 400. So we're going to have 400 unit square. So now we're going to find the area of our circle. So I'm going to put circle. How do we find area of a circle? So if you go to this, your formula sheet, you see area right here and you see circle right here. So area is going to be pi r, which is the radius, square. So we're going to have equal pi. Now remember we said that the radius of the circle is going to be the 5, not the 10. The 10 is the whole thing. That's the diameter. The radius is going to be 5. So we're going to have 5 square. And we're multiplying. So this means that we're multiplying. So you can go to our calculator and we're going to have pi. Right here is pi. Parentheses 5 square. Close parentheses. Enter. So that's gonna be 78.54 if I round it off to the nearest hundredth. Now be careful. This is the area for just one circle. But remember, we have 2 circles. So this half and this half makes one circle. This half and this half make another circle. So we have 2 circles. So this is the area of one circle. So it means that the area of the other circle would have to be the same because they are identical. So I'm going to put times 2. Why? Because we have 2 circles. So that's going to have that times 2. Enter. So the area of our 2 circles is going to be 157.08. Now to find the area of the shaded part, we're going to have the whole area, which is a square. So we're going to have the square minus the circles. All right. So the area of the square we have is the 400 minus the circles is going to be 157.08. You can just use your calculator quickly. 400 minus 157.08. Enter. So then our answer is going to be 242.92 unit square. So in this one, when you get the area of the square and the circle, you will not add. Over here, we added because we wanted the area of everything. Over here, we only want the area of what is shaded. So because we don't want the area of everything, then we have to subtract. Okay? And how do you subtract? It's always going to be the area of the entire shape. So my entire shape is the square minus the unshaded, and your unshaded is going to be our circles. So that's why, and it's always going to be the bigger number. It's always the bigger number minus the smaller number.